Welcome, ladies and gentlemen, to Math AI. AI stands for Applications and Interpretation. This is my first recorded lecture I'm doing with my specific thing. I'm using Microsoft's built-in Xbox game recording software. So this is basically like Twitch, so don't forget to hit that bell, like, and subscribe. Oh wait, that's YouTube. Anyway. Okay, so this is the way this class is organized. Is there's a variety of topics. Eventually, in your next year, we're going to build up to calculus. This year, we're going to start with some basics that are going to be carrying throughout the course. We'll learn some statistics, some geometry, special things about functions, and for those of you in HL, we're going to be doing matrix modeling. Although I don't believe that anyone's signed up for HL at this point. This first chapter is fairly simple. We're going to talk about significant figures and approximations, rounding, and things like that. So, there's a very old joke about a night guard at a museum. Here, this will be the night guard, where the students come in to ask him about the dinosaurs. He says, "Oh, these dinosaurs are 65 million and 3 years old." And they say, how can you know so precisely? He's like, "Oh, because I started working here 3 years ago, and back then they were just 65 million years old." So it's a stupid joke, and it's going to get even worse as I explain it. But his idea was that he took his amount of time, which is 3, and 65 million, and added them together to get 65 million and 3. Okay, this obviously has some problems. If you want to stop the video and think about that for a little bit, it might not be a bad idea. What is wrong with this concept? Okay. Well, lots of stuff is wrong. The main thing is I'm going to write this down. We use the least accurate measurement when deciding how to round answers. So, this is the principle of significant figures. So I want to see if you guys can remember what significant figures are. So again, I suggest that you try pausing the video and thinking, what is a significant figure? I promise that pausing and thinking will help, because in this class, and in all math classes, it's the effort to try to learn and to reach beyond your boundaries that actually teaches you. Just hearing me drone on and on doesn't help you nearly as much as you trying. Okay, so a significant figure is the digits that we can specify accurately. So one example of that is I am 5 foot 10 inches, which would make me exactly 70 inches tall. And so that's two significant figures, because I know I'm not 71 inches tall, and I know I'm not 69 inches tall, but I can't say anything more than 70 inches. I don't know if I'm like 70.5, 70.2, and it actually changes throughout the day. Another example is that acceleration due to gravity is 9.8 meters per second squared. Now, we might be able to be more specific than that, but the honest truth is the Earth's crust changes in size so much from point to point that gravity is actually a different value on top of Mount Everest, for instance, than it is in the thinnest part of the ocean crust. And it actually can go between 9.79 and 9.83 or something like that, I'm not sure. So 9.8 is actually the closest that we can really specify with any accuracy. So that is also two significant figures. Okay, so our rule is going to be when doing, we use the least accurate measurement to decide the right answers. What that means is your answer should have the same number of significant digits as the smallest, number that you used that has the least significant digits. Okay. Let's do a couple examples. Okay, so this has 2 significant figures, and this has 3 significant figures. Great. So let's say we want to find the area. I'm doing example 1b. To find the area, we do 17 times 97.1. This part we do to complete accuracy. Divided by 2. The formula I'm using here is 1/2 base times height. If you don't remember these formulas, this is a good chance for you to get some practice. If you look at 1a, it also does the Pythagorean theorem. Okay, so if we work this out, then as the book says, we get 812 point. I just realized I've made a big mistake here, and I'm going to skip this part of the video. Okay, so let's do part 1a. So to do part 1a, we're going to use Pythagorean theorem. Find the hypotenuse. We have the hypotenuse, and we need to find x, which is the other edge. And we're going to use the Pythagorean theorem here. So according to Pythagorean theorem, 97.1 squared equals 17 squared plus x squared. Now we can type into Google 97.1 squared to get 9428.41. Now, we talked about rounding. You don't round until the very last step of the problem. If you round too early, you'll actually cause yourself more problems. 17 squared, we can do that without a calculator. That's 289. Okay, but now to find x, we need to subtract 289 from the numbers on the right. So 9428.41 minus 289. And feel free to pause at any time. That gives us an answer of 9139.41. And that is the square root, or that is x squared. We now take the square root of both sides. So I'm going to square root this. We get 95.60026. So just checking that again, 95.6002 ... Okay, so this actually has quite a bit of information. The book has this to 4 decimal places. So if we want to do 4 decimal places, the next number would have been 5. So to round this to 4 decimal places, we would actually have to cut this off here and then round up. And so we round up because you always round up 5s. This is 95.6003. Now, we just did this because the book asked us to for part 1a, part 1. But for part 2, we're supposed to round it to the correct number of significant digits. And the correct number of significant digits here is 2, because 17 has 2 significant figures. So this becomes 96, because we cut it off after 2 digits and we round up. So 96 of whatever units this is, I think it's centimeters in the book, 96 centimeters is the height of the leg x. Okay, so I'm going to erase that part now. Now the book wants us to find the height. Or sorry, not the height, the area. We're going to use area equals 1/2 base times height. Now you may think that we should use 96 as the height. However, that is not correct. I want you to stop the show for a little bit and think about why that's not correct. Okay, so the reason it's not correct is because I said before that you should only round at the very last step of a problem. Since this is a new problem, its very last step is going to be the area. So we're going to use all the information that we have, the most accurate that we have, until the very last step and then round. Because the rounding, it doesn't help us do the math. all the rounding is for is to make sure that the answer we get is reliable. That we know how reliable it is. That we don't make that guy's mistake of saying there's dinosaur bones that are 65 million and 3 years old. So this is going to be 1/2 times the base, which is 17, times the height, which is that really long number, 95.600, ... So let's go over here. We still have that number saved, so we times it by 17, divide it by 2, to get 812.6022. Now, before I go back to the other screen, remember, the original problem had 2 significant digits. So how do we simplify this to 2 significant digits? The answer is going to be 810. It would have been 812, but we cut it off after 2 digits and we round to whatever. So the 2 becomes a 0 from rounding. Okay, let's stop here for now.